Hi, hello friends. Welcome to the today's session. Welcome to Unacademy and welcome to Srinivasarao Sir class. In this session, we are going to discuss about the different problems on supernetting and subnetting of IP addressing. So before entering into the session, let us all say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. My dear friends, we all know that Unacademy has created wonderful digital content with dedicated faculty members to serve the dedicated students. So all you need to do is join into Unacademy and get the benefit out of it. And myself is Srinivasarao IS, having more than 15 years of experience in the GATE with the various subjects. I also had industry experience in the database side and the systems side with the relevant good certifications. And I taught in many premium academies throughout my career, and many of my students got completed their post graduation from IITs and IIT center places. My dear friends, you also can achieve such kind of success just by clearing a GATE examination. So to clear the GATE examination, there is a proper guidance and shortcut tips from the experienced faculty members. And I really proud that many of my students are also acting as a GATE mentors in the CS stream. So there are two kinds of subscriptions are there in an academy. So one is a plus course, the other one is iconic batch. So my dear friends, if you want 1:1 guidance program, you better to opt to iconic batch. And plus course intensively that you're having a dedicated lectures, live sessions, live quizzes, mock sessions, whatnot. Everything, including of your quizzes are there. Once you become a premium student, then you can able to utilize all of them. Your restrictions are going to be cleared. So the subscription prices are as like this. So according to Plus, the three subscriptions are 12 months, 18 months, and 24 months. If you apply my referral code, then you're going to get a maximized discount on that. So my dear friends, utilize this opportunity what the Unacademy is giving you. Apart from top quality content, you also will get maximized discounts on the subscription prices. So after applying my referral code, you are going to get, these are the prices you are going to get. So the second subscription is iconic batch, where you're going to have 1:1 personal guidance, including of your plus course. So there are two subscriptions, 12 months and 24 months. If you use my referral code, then you're also going to get a maximizer discount on that. These are the final prices after applying my referral code. My dear friends, my referral code is also eligible for any kind of course which is available in an academy, and not only for GATE and ESE. Let's Crack GATE CSE is our YouTube channel. Subscribe our YouTube channel. Use my referral code to get the admission into an academy. Hit the bell icon for latest notifications and updates. So dear friends, let us start the first question on supernetting and subnetting. Let us say, Class C network propose an appropriate subnet mask to have 7 subnets, each with 25 systems. So Class C we want with 7 subnets and each with 25 nodes. So what is the mask? He is asking what is the mask. If you know, Class C is nothing but a triple N and H is the format. Therefore, my dear friends, the masking of HID is a concept of a subnetting, and masking of your NID is a concept of supernetting. Therefore, here we are trying to manipulate because he asked us to provide a subnetting concept. So 7 subnets means how many number of bits you need to do a subnetting. So 2 power log base 2 of 7, which is nothing but 3-bit subnetting we need. Therefore, my dear friends, so you're going to get triple N and our H is with a 3-bit subnetting. What is the meaning of 3-bit subnetting? Triple 1 and the remaining are zeros. So these 3 ones you can able to place anywhere. It need not be a contiguous, but if you have a contiguous, it is going to be proposed. You can also go for random. So this is a one mask. What is your mask? 255.255.255.224. It is the most preferable. I can also have in a different scenarios. I can keep here and the remaining are going to be zeros, or I can keep randomly and the remaining are going to be zeros. So these are all eligible only, but most preferred one is contiguous ones are most preferable. So according to that, you please see that 224 is eligible, 7 is also eligible. What is the meaning of 7? Last 3 ones. And 41 is also eligible, as well as 67 is also eligible. Because in 41, you see that only 3 ones are there. 128 is off, 64 is off, 32 is required, and 16 is off, and 8 is off, 8 is required, right? So 8 is on, so 32 plus 8, it is a 40, and 4 to 1 is on. So 3 ones. This is also valid. As well as 67 is also valid. Why? Because 128 is off, 61, 64 is there, 32 off, 16 off, 8 off, and 4 to 1. 4. So 64, 4 is also off, 2 and 1. So 64 plus 2 plus 1, it is a 67. Therefore, all are eligible. But what is the proper one? The best answer according to current internet technology is consecutive ones, which is nothing but uniform splitting only. Now let us see the second question. So here is the second question. This time he is asking class B network. Class B network means immediately need to strike. What is that? Double N HH. What is your mask? It is a 255.255.0.0. That means there are 8 zeros are there here. Here also 8 zeros are there. Now what is asking? 150 subnets with 200 systems. 150 subnets. So 150 subnets are nothing but log base 2 of 150. So log base 2 of 150 is nothing but 2 power 7 128, 2 power 8 256. So I'm going to take 8-bit subnetting. So 8-bit subnetting I am doing. And each subnet requires how many? So 150 subnets, we got 200 systems we need. 200 systems. Yes. This complete octet I can able to use it for subnetting. And this one is completely for what? So 200 systems means, let us put it here, 200 nodes. So what is a log base 2? It is the log base 2 of 200, which is nothing but 8 bits HID. That means 8-bit zeros required and 8 bits for ones required. So you can write here, you can write here, you can write, no problem. But mandatory is that here 4 ones you can write, 4 ones you can write there, no problem. But mandatory is that consecutive ones are going to be supported, but remaining are also valid. So total 8 ones from HID we need and 8 zeros we need. So let us say that this is HID part, this and this is HID part, this and this is HID part. Let us confirm it. Option A, 255.255.1234567 1 2 3 4 5 6 7 8. So 8 ones 8 zeros, therefore option A is correct. Option B, let us check, are there 8 ones and 8 zeros are there or not? 240 240. So 255.255.240.240. So this is H, this is also H. 240 means 8 ones, sorry, 4 ones 4 zeros. And here also 240 means 4 ones 4 zeros. Therefore, this is also eligible. And option C, let us see. What is option C? So 255.255.192.252. So what is 192? Double one 6 zeros. And what is 252? So what is 252? 1 2 3 4 5 6 double zero. So 6 ones and 2 ones, 8 ones, 2 zeros and 6 zeros. Therefore 8 zeros and 8 ones. This is also eligible. All are appropriate subnet masks only according to your design, but the preferable one is only option A, because uniform consecutive zeros and consecutive ones we require. Okay, now let us see another question. Consider class C network, propose an appropriate subnet mask to have 20 subnets. So let us see class C subnet. Class C subnetwork. So class C is nothing but triple N and H, which is nothing but 255, 255 and 255, 8 zeros. This is your class C default mask. What is asking? 20 subnets. 20 subnets, each with 15 computers. So what are the total nodes now? So total host are 300, which is greater than your limit. What is your limit? You can have only 256 HIDs only. So 300 greater than 256 capability. Therefore, we cannot afford. We cannot afford. Therefore, what you need to do? Go, just use class B. So use class B subnet. Okay. So this is idea. This is invalid according to your class C. This is invalid. It is not possible in class C network because the class C can give you maximum 256, but you're asking 300. And next question is like this. Consider list of IP addresses 192, 1.0, 2.0, 4.0, 10.0. Can we put it in the CIDR format? We will say no. Why we will say no? You want to put it in the CIDR format, 3 rules you have to follow. What is rule 1? The blocks must be consecutive. Blocks must be consecutive. But here blocks are not consecutive. Why? 1, 2, 4, 10. Therefore, rule number 1 failed. So, rule number 2 and rule number 3 you need not check because rule number 1 is failed. Okay. So, it is not a CIDR format representation. Let us look at the next another question. How many valid IP addresses does the network /26 contains? So when we talk about the /26, it is CIDR format only. So 26 ones in the mask. 26 ones in the mask, right? So remaining all are zeros. How many zeros are there? Remaining are 6 zeros are there. 6 zeros in the mask. Okay. So let us identify starting block number and ending block number of CIDR. How to identify starting block number, ending block number? Write your IP. Right? So 8 zeros are there. This is a 0 according to the given. So 6 zeros from right towards to left. This is your HID part. Right? Now you tell me. This is completely NID part only. Because 26 ones are nothing but 26 ones are nothing but it is NID. Up to that part it is NID only. And the remaining part is HID. So you want to find the block number. What you need to do? Just convert your HID into zeros. And you want block ending number. Block ending number is nothing but block broadcast. You want to find a block ending number, convert them to ones. So you please drop as it is remaining positions. So my dear friends, you observe what is your answer? Your starting number is 0, ending number is 63. So how many IP addresses are there here? How many IP addresses are there? 6 zeros are nothing but 2 power 6 minus 2. So 64 minus 2 is nothing but 62 is your answer. 26 ones and 6 bits are for HIDs. Hence 2 power 6 minus 2 is your valid HIDs. What are the range of HIDs? Yes. The starting number is 0 and ending number is 63. So 0 to 63. This you cannot use, this you cannot use. Starting 1 is a block number, ending 1 is a block broadcast number. So you can use from 1 to 62 numbers. Let us look at the next question. Let us crack it. So what is the broadcast address? Broadcast address is nothing but ending block number only. Let us take this number. We know how to do it. 172.16, 176.0 slash 20. What is the meaning of 20? 20 ones in the mask. They're all net ID only. So remaining 12 bits are zeros. 12 zeros in the mask. So we want to take 12 zeros. So right to left I am talking. 8 zeros are here. 4 zeros are here. Therefore, your 172.16.176.0, this is your HID part, 8 bits, and here also some bits are NID, some bits are HID. 4 bits are NID and 4 bits are HID because you need 12 zeros in the mask. So let us write 176 in binary because some bits are NID, some bits are HID. So what is a 176 binary? So 128, 64 and 32, 32 on, 16 on, remaining off. That's it. And 0 binary. So you want block number, starting number and block broadcast address. Broadcast address. So what you do? Drop as it is. Convert your host IDs to zeros. So this is completely HID only and this is a completely NID. So drop them. 1011, 1011, 1 for broadcast, 1 for the starting block number. So make them two zeros. Luckily they are all zeros only. Make them two ones. That's it. So what is your answer? Your answer is 172.16.0 and this is 176 plus 15, 191.255. So the fourth octet is asking valid broadcast address. This is your valid broadcast address. The ending number is 255. And third octet value is 191, second octet is 16, and first octet is 170. Your starting block number is 172.16.0, 176.0. Don't forget that. Let us crack next question. So it is also CIDR representation only. So /26 is asking same question. First by first address and last address. Let us take 193.18.41.177/26. What is the meaning of 26? 26 ones and how many? 6 zeros. So 6 zeros are your HIDs only. 26 ones are nothing but NID only. So let us write left to right. 26 ones, right to left, 6 zeros. So this you need to write. 177 right in binary. So 128, 64, 32, 16, 1, 2, 3, 1. This is the binary of 177. Remaining as it is you can write because they are all meant for NID only. NID, NID, and NID because 26 ones. So 8, 8, 8, and here 2 more bits are there for NID. This is also NID. And the last 6 bits, whatever are there, that is your HID. So give a gap. So you want starting block number. So drop as it is 193.18.41.10, and these are all supposed to be zeros. And you want block broadcast address. Same, drop NID 193.18.41.10, So what is the starting number? 193.18.41, 193.18.41. What is the next one? It is 128. Yes, it is 128. What is the last number? 128 plus 2 power 6, which means 63. 128 plus 63. It is 191. So option A is correct. Starting number is 193.18.41.128. Please convert into decimal. And next one 193.18.41.191. This is your ending number. Okay. Now let's crack the next question. So /27 by giving this number. Same first address, last address is asking. So 200.10.11.144/27. What is the meaning of /27? 27 ones, 5 zeros. 27 ones and 5 zeros. 5 zeros means this octet you just write in the binary. Remaining are NID only. So therefore 200 is NID, 10 is NID, 11 is NID. In 144 also few bits are NID, few bits are HID. HID how many? 5. Remaining 3 bits are NID only. Right? 144 binary. So 128, 64, 32, 16, 1, 2, 3, 4. This is 144 binary. So in that 5 are zeros right to left. This is your HID. And remaining are NID only. So in that 8, 8, 8, 24 and 3 more are there. So up to here it is NID. So you want block starting number. So drop as it is NID points. Convert them HIDs to zeros. And you want block broadcast. Drop as it is NID. Convert them to ones. So what is your value? The block starting number is 200.10.11.128. What is the block ending number? 200.10.11.128 plus 31 is 159. But we don't want, he is not asking block broadcast. The fourth octet of the last IP address of the network which can be assigned to host. So you cannot assign this, you cannot assign this because they are reserved. You can use only middle numbers only, that is 129 to 158. So your answer is last number which can be used as a 158, first number which can be used as a 129, because 128 and 159 are reserved because they cannot be used. Okay. Let us crack the next question. He is asking you to do 2-bit subnetting. So be careful. Very, very important question this is. So 192.168.100.0/20. What is the meaning of 20? 20 bits for NID network. And 2 bits we are doing subnetting plus 2 bits for subnetting. So total your reserved how many? 22. And the rest 10 bits are HIDs. Rest of the 10 bits are HID. So what is your latest value now? 192.168.100.0, 20 plus 2 bits. It is 22. Okay, my dear friends, because 20 bits NIDs you need to drop as it is, and 2 bits are reserved for subnetting, and the remaining 10 bits you can able to use for what? Host ID, which can be made to zeros, which can be mixed to ones. So this is a very latest question of GATE examination. Very latest. Please see how I solve this question carefully. So 1500 computers I need. That means 1500 IP addresses. You want 1500 IP addresses means log base 2 of 1500. Then you will come to know how many zeros required. 2 power 10 means 1024. 2 power 11 means 2048, which means we want to take 2 power 11 greater than 1500, which means 11 bits for HID, zeros. 11 bits for HID, which are nothing but zeros. So remaining 21 bits are for what? NID, and some are subnet ID, because he said that /17. What is the meaning of 17? 17 once means 17 NID bits. But he is asking 11 HID means 17 NID means the remaining 4 bits are for subnet ID. Observe carefully. Let me write. 202.61.0.0/17, which means 17 network bits. You cannot change them. And how many zeros required? 17 HID bits. So 17 plus 11, 28, right? So remaining 4 bits for subnet. You need to guess like that. Remaining 4 bits for subnet. So all together now you got 32 bits. So what is your latest mask? Therefore your latest mask is 202.61.0.0/27 NID plus 4 bits subnet. Therefore it is So 17 bits NID and 4 bits subnet ID. So your new answer is /20. So you choose the answer which has got /21. They are all correct only. Let us see. /21. Yes, correct, correct, correct. You cannot eliminate any answer because all are with the /21. Now you need to find carefully subnet IDs because he is mentioning subnet ID. First two octets are common everywhere. Please see. He is asking only third octet only because last octet is also common everywhere. Only third octet, whether they are eligible for subnet IDs or not. So how to identify different subnets in this scenario, I will show you. Listen carefully. So you please observe 4-bit subnetting I am doing, right? 4-bit subnetting we are doing of third octet. This is very important. Which octet? Third octet. Why third octet? Because 17 bits are NID. So first octet is 8 bits. Second octet is 8 bits. That means we don't disturb first octet and second octet. Our main intention is third octet only. So third octet you need to write 1 bit for NID you need to reserve and remaining subnetting and remaining HID. Observe carefully. I will write 4 parts in that. What is that? 17 bits NID plus 4 bits subnets plus 17 plus 4 21 11 bits HID. Okay, so I will write the given IP in this format only. What is that? 202 61 0.0. This is your NID. This is your NID. So total 16. Here we want to take one more. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? This is your HID. Zero and 0. And how many zeros required? 11-bit HID means zeros only. Right? So 11 bits zeros. So from here to here, it is your HID part. 11 bits are HID from right towards to left. Now 17 bits are NID. So 8 ones and 8 ones and one more one is also required. This is also NID. Give the gap. And the remaining 4 bits whatever are there, they are subnetted. That's it. You got your answer. So 17 NID bits, 4 bits subnetting, 11 bits HID. So write the permutation combinations of your 4-bit subnetting. First one is 4 zeros. 0 0 0 1, 0 0 1 0, 0 0 1 1, 0 1 double 0, 0 1 0 1, 0 1 1 0, 0 1 1 1. You can also write shortcut, but let me show you process. 1 triple 0, 1 0 0 1, 1 0, 1 1. So you got 16 combinations. Why 16 combinations? Because 4-bit subnetting means how many subnets you will get? 4-bit subnetting means number of subnets are 2 power 4, which is nothing but 16 subnets you will get. Okay, so 16 subnets. And in that octet, this is your third octet, this is your fourth octet. In that octet, 3 bits are reserved. per HIDs. So number of HIDs in your third octet is 2 power 3, which is nothing but 8. And starting number is 0 because that is an ID. Okay. Now you read what are the subnet numbers. The first subnet number 0. First subnet number is 202.61.0.0. Next subnet 1248. 202.61.8.0. Next subnet is 16. Next subnet is 24. Next subnet is 32, 40, 48, 56, 64, 64 plus 8, 72, 80, 88, 96, 104. This is how you are going to get 16 subnets. Okay. Are the given answers are in this list of subnets or not? Let us see. What are given answers? 84, 104, 64, 144. 84, 104. 84 is not there. 104 is there, yes. So therefore, I can confirm that 104. This is 1. And 64 is also there. Please look at. 64 is also there. And what is the next one? 104 is 104 is there. So 144 next one. So 144 is not there. Because you're going to get 16 combinations only. 1, 2, and 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, and 16. So these many subnets you know. So this is how you can understand that. What is our answer? The answer is, so 2 and 3 are eligible for this hierarchy. So let us crack one more question. Find a number of small networks to be combined to generate 1000 HIDs. So this is he is asking from class C network. So 1000 HIDs means how many zeros? So 10 zeros. So 10 zeros means according to class C, n dot n dot n dot 1 2 3 4 5 6 7 8. This is your HID. How many zeros are there? Only 8 zeros are there. So we need to borrow from the network part. So 1 2 3 4 1 2 double 0. So I got. Now you got 10 bits HID. That means how many bits you borrowed? So 2 bits I borrowed. That means number of bits borrowed is equal to 2. So how many supernet blocks? How many supernet blocks are combined? It is nothing but 2 power 2. So 4. So 4 class C networks are combined. So there is a shortcut for this. What is that? Each class C can give you 256 HIDs, not more than that. So 256 and 256 and 256 and 256, you got 1024 bus. Otherwise, you require 1000 IPs divided by 456. I come to know that 4 class C networks are combined. 4 class C networks are combined. Very simple to answer. This is the shortcuts. So your answer is 4 class C networks are combined. Next question. Number of supernet blocks he asked. So this is the mask is given. 255.255.224.0. Is it subnetting or supernetting? Let us understand. Class C. So network is manipulated. Whenever network is manipulated, here network ID is manipulated or network bits are manipulated or network bits are borrowed. Therefore, it is a supernetting. So when you say that it is a supernetting, how many supernet blocks are there? How many dash supernet blocks? Your supernet blocks are nothing but number of bits you borrowed. Dash bits borrowed. How many bits borrowed? So 3 bits borrowed. 224 is nothing but how many bits borrowed? 1, 2, 3, 1, 2, 3, 4, 5. So 5 bits borrowed. How many bits borrowed? 5 bits borrowed. Because after writing this 224 into the binary, it is a 111 and 50. Therefore, 5 bits are borrowed. So number of supernet blocks are nothing but 2 power 5, which is nothing but 32. So you got 32 here. So 32 class C networks are combined to generate a big larger network. And each class C network can give you 256 HIDs. How many HIDs? Dash HIDs. If you ask the question, simple. What is that? 32 into 256, you will get the answer. These many HIDs are there. So roughly 2 power 13 HIDs. Let us crack next question. So starting block number of your supernet is asking. Let us take IP. Please revise my supernetting classes, which I already told you in the last session. Then only you can able to answer this questionnaire. So 255 and 255 and 248.0. Is it supernetted or not? Yes, exactly it is supernetted under class C. Why? Because your NID part is manipulated in the mask. In the mask, your NID part is manipulated. That means your 248 can be written in the binary in such a way that 5 ones and triple zero and 0 0 0 0 0 0 0. And he is asking what is the starting block number. So write your IP into the binary. So 200 point and 100 point, here only manipulation happened, right? So write that 100 into binary and 0 also into binary. IP I am writing. So this is a N, this is a N, and in this N and H are there, this is completely H only. Right. So write 100 into binary. 0 11 0 0 1 0 0. 1 2 3 4 5 6 7 8. Now listen carefully. How many bits are supernetted or how many bits are borrowed? How many bits are borrowed? These are the borrowed bits. That means these ones becomes 0. So you got borrowed 3 bits. Therefore, this is completely your HID part. And the rest is your NID part. So drop it. 200.100.01100, and they are going to be zeros. That's it. He asked starting block number only. Ending block number means again you will see that HIDs must be ones. HID part must be 1. And this is as it is. So what is your answer, my dear friends? This is your starting block number. What is your starting block number? Decimal 200 point, 100 point, 64 plus 32, 96.0. Okay. Let us solve one more question. Class C mask. It is supernetted. Why? Because NID is manipulated. So actually your default mask is 255.255.255.0. This is your default mask of class C. But how much is given? Observe how much is given. So 240 is given. 255.255.240.0. So he is asking number of HID means how many zeros are there. So these are all ones only. All ones, all ones, all zeros. 1, 2, 3, 4, 5, 6, 7, 8. 240 means let me write in binary. 1, 2, 3, 4, 1, 2, 3, 4. So how many zeros? 2 power 12 zeros. So number of HIDs are 2 power 12 minus 2. So your answer is 4094. And the next one is block broadcast he is asking. Earlier he asked about the block starting number. Now he is asking block ending number. Let me do this. So first write your mask in binary where manipulation is happened from 1 to zeros. Which octet? Third octet is manipulated. So 255 it is NID. 255 it is NID. 248 some NID, some HID, and 0 this HID. So let us write this 248 into binary. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. How many bits you borrowed? So from third octet, we borrowed 3 bits. Okay. Now write your IP. Your given IP is, this is NID, we are not going to touch. This is also for NID, we are not going to touch. But in this octet, in this third octet, some bits are NID, some bits are HID. Therefore, write that into binary. So 0, 1, 1, 0, 0, 1, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So you want block start number and block ending number. So 3 bits. This is completely HID part. Observe. From here to here, it is HID only because 3 bits are borrowed for HID. So drop them, remaining as it is. So 200 point, 100 point, 0, 1, 1, 0, 0, 0, 0, 0. Make HIDs to zeros and make HIDs to ones. So this is a 200 point and 100 point, 0, 1, 1, 0, 0. So what is ending number? This is only your ending number. Your block ending number is 200 point, 100 point. What is the value? 96 plus 7, 103.255. This is the block ending number. Now let us solve one more question. He is asking supernet block numbers. This is a very interesting question. Supernet block numbers he is asking. First, let us see that whether it is supernetting or not. So 255, 255, 252.0 and class C na. So N, 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 H. But this N has got some H also. So whenever NID is manipulated, supernetting is done. Supernetting is done. So he is asking how many supernet blocks and what are the supernet blocks? How many bits borrowed? That's very, very important. Dash bits borrowed. So let us write this 252 into binary. 1, 2, 3, 4, 5, 6, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So how many bits you borrowed? Please observe carefully. Only in this octet, once becomes two zeros. That means 2 bits are borrowed. So 2 bits are borrowed. When 2 bits are borrowed, a number of supernet blocks. Your number of supernet blocks are 2 raised to 2, which is nothing but 4 supernet blocks. So what are your blocks? What are your supernet IDs? He is asking. Okay. Now this time write your IP into binary. What is your binary? Please observe carefully. This is NID. We are not going to touch. And 16 also NID. We are not going to touch. Third octet is some bits are NID, some bits are HID. That I want to write in binary. 96. 0110 0000 and last is 0 because last octet is purely for HID only. Now 2-bit combination you tell me. So last 2-bit combination. What is your last 2-bit combination? Because those bits are only borrowed. What is your last 2-bit combination? It is 00 01 10 11 and remaining as it is drop it. 192 16 0 again 0 again 0 192.16. That is a common as they are treating as NID. So what is your answer? First one is 96, second one is 97, third one is 98, fourth one is 99. This is your answer. So your starting block number is 96, ending block number is 99. You got 4 supernet blocks exactly. Okay. So what are your block supernet numbers? 192.16.96.0, 97.0, 98.0, 99.0. Let us crack one more question. So 3-bit supernetting we are doing. So it's a very simple question. 3-bit supernetting is nothing but what is your new mask, supernet mask? So class C, it is a n.n.n.h. So 255.255.255.0. So 3 bits are borrowed. That's the meaning of 3-bit supernetting, means 3 bits are borrowed. So from this octet we are borrowed. This is a fixed. This is a fixed 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Okay, this is fixed HID. Now here this and this and this are borrowed. So now you read what is your new mask. What is your new mask? Your new mask is 255 point. How many ones are there? 5 ones are there. 5 1 means 248.0. Option D is correct. Now let us crack one more question. So find the number of bits to borrow to generate 1000 HIDs. Number of bits borrowed to generate 1000 host IDs. So naturally in class C network, 8 bits are there with you for HID. So how many bits you need to borrow to generate 1000? This will give you 2 power 8 only, 256. So I need 1000. 1000 means how many zeros required? 1000 HIDs means we need log base 2 of 1000, which is nothing but 10 bits for HID. So 2 bits you need to borrow from this place. So your answer is 2 bits. So as you borrow 2 bits, so 2 power 2 is nothing but 4 supernet blocks you will get. Is the given IP eligible for supernet ID? That means supernet ID is nothing but starting block number you have to get. If you get the starting block number, then it is SuperNet ID. Otherwise, it is not eligible for SuperNet ID. So let us see that. Is this one is our starting block number? First, let us take the mask. So supernetting happened because NID is manipulated. This consists of NID plus HID. This consists of HID. So let us write this into binary. 1, 2, 3, 4, 5, 6. 252 means 6 ones and 2 zeros. Remaining fourth octet is 8 zeros. Right? So from here to here, it is a completely HID only. And the remaining are NID. Write your IP in the binary now. What is your IP? 192.168.100.0. So this is NID. I am not going to touch. This is NID according to given. I am not going to touch. But this is consisting of some NID, some HID. This is HID. Okay. So write this and this into binary. So 100 binary and 0 binary. So how many bits are for HID? 10 bits are for HID. 8 bits here, 2 bits here. So leave that gap. So drop it as it is now. 192.168.0110 and write subnet ID. What is your subnet ID? Make HIDs to zeros. This one is reserved. Don't disturb. Make HIDs to zeros and make HIDs to ones to get the broadcast address. So HIDs to ones. That's it. So he is asking subnet ID only. What is your subnet ID? You got 192.168. So 96 plus 400.0. Yes, it is eligible as a SuperNet ID. Well, my dear friends, so this is our last question on supernetting and subnetting. So consider list of IP addresses. And what is the new supernet mask after aggregating the above? Very simple. How many supernet blocks you got? So 4 supernet blocks. 1, 2, 3, 4 supernet blocks. 4 supernet blocks given. So how many bits are borrowed? Can you guess? Log base 2 of 4 is nothing but 2 power 2, which means 2 bits are borrowed from third octet. 2 bits are borrowed from third octet. Therefore, write your third octet after excluding your 2 bits. This is your default mask, so I got borrowed 2 bits. So what is a new mask? 255.255.252.0. This is your. So this is how to identify a new mask by taking some kind of subnet. Well, my dear friends, we will close the session using this example. What is the new supernet mask after combining 64 small networks? 64 small networks means dash bits you need. So 6-bit supernetting I am doing. That means 6 bits are manipulated. 6 bits are borrowed from third octet, because third octet maximum capacity is 8 bits. Okay, so let us write 255 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7. So N H. Now 6 bits you make as 0. 1 2 3 4 5 6. So what is a new mask? Double 1, which is nothing but 190. Thank you very much, friends, for sparing your valuable time. Please use my referral code to get the admission into Unacademy, to get the many more things, to get all my experiences. Once you listen my classes and practice at yourself, then you are going to be perfect as like me. You can also become a GATE mentor or a GATE faculty, either offline or online. So please use my referral code to get the admission into Unacademy and get a maximum discount also. Please share this knowledge to all your friends and stay tuned to Unacademy. Please do like every of my lecture. Please stay tuned Unacademy and stay tuned to Srinivasarao Sir classes. Thank you very much.